Alright, hello everyone. Here we are looking at Unit 2, Lesson number 7, and our topic is the rate of change. So for today, our learning goal is that the rate of change compares the vertical and horizontal change on a line. Okay, so we should all be remembering these words, but vertical is moving up or down, and horizontal is moving left or right. The rate of change is shown as the rise over the run, where the rise is the vertical change and the run is the horizontal change. So we look at our vertical over our horizontal change to get our rate of change. Our success criteria is to determine the rate of change of a line, and our practice is Activity 7, Rate of Change, which is linked directly in our hub page. So for today, we're going to try out a Tips for Revised Math lesson. So this lesson slide was actually generated by another group of teachers for teaching this class. We thought that we would give it a shot and see how people like these types of lessons. So our topic, again, is rate of change, and we are looking at how our line changes vertically and horizontally. So here we see the rate of change of a linear relationship. We have our rise, which is the movement from our first point up to the height of our second point found over here. And then our run is our horizontal movement across from the starting point to the finish point of our two separate points. So when we are determining rate of change, we have to make a ratio or a rate, because we know that we've used ratios and rates back and forth. So whenever we're doing this, we say that we have a rate of change based on our rise over our run. So we're looking at how much we change up or down, and we look at how much we change moving from our first point to the right over to our second point. So we see here just a formalized version of what we saw on the previous slide. There we have our equation for the rate of change, and we have a statement that the rate of change of a linear relationship is the steepness of a line. And that word steepness is describing how quickly the line rises. So we can have a couple lines here. If the line moves slowly in an upward direction versus if the line moves more rapidly in an upward direction, all the way up to the most rapid. Our green line is our steep line, our blue line is less steep, and our red line is not very steep at all. So for the next few slides, we're going to look at rate of change in terms of being a real-life scenario. So we can see rate of change in the steepness of a roof. This image down here is a little distorted, but it's showing the steepness of a ramp. And last of all, we can see how the roads move upward or downward to create a new type of rate of change that we'll discuss in a few slides. So first of all, the steepness of the roof of a house is referred to as the pitch of the roof by home builders. So this word here, pitch, whenever you see us referring to pitch, we are talking about the rate of change seen from the bottom to the top of the roof. So we would start at the bottom, we would get our rise, and then we would get our run to get to the top. Notice on these A-style roofs that we would only use half of it because we construct a triangle and then use the hypotenuse to get our rate of change. So, if we were asked to give one reason why some homes have roofs which have a greater pitch, it really comes down to where you live. If you live somewhere where it's not very snowy, then you wouldn't need as steep of a roof. If you think of houses in California or Arizona or other warm locations, oftentimes they'll have a flat roof. Whereas northern climates, like in Canada and Europe and Russia, we see that roofs have a steep rate of change in order to allow the snow to melt off of it easily. Another name for rate of change is grade. We see that engineers refer to the rate of change of a road as the grade because they measure how the steepness changes as you're driving along it. Often that would be shown as a percent. Here we see a sign representing the grade of the of the road. In this case, the grade is 8%. So, we're given a question here. We see a road shown with the green line, and they measure two separate points. Here's our first point, here's our second point. We see that we have a rise of 8 units right here, and we have a run of 100 units right here. So in order to determine our rate of change, we're going to put our rise over our run. Well, our rise is 8, our run is 100. So our rate of change would be 8 over 100. Now we can put that into our calculator and we would get 0.08 times 100% in order to give us our 8% grade. After you divide, you need to remember to multiply by 100% in order to get your grade. Okay, and this is just the finished slide. It's a little bit neater and it's easier for you to copy down onto your notes. Here we see another example. This time we're looking at a ramp. So the steepness of wheelchair ramps is of great importance for safety. If your ramp is too steep, then it's very difficult for a wheelchair to get up that ramp. It's also very dangerous going down because you would accelerate very quickly. So here we see our wheelchair ramp have a rate of change with a rise of 1 and a run of 12. So they've put the rise up top, they've put the run down below. Now, this rate of change of 1 to 12 tells us its steepness. It also allows us to do some work. For example, if we needed a taller ramp, if we needed a ramp that goes up 1.5 meters, how could we figure out the run? Well, in order to do a question like this, we need to make equivalent ratios. So thinking back to the work that we did in unit number 1, 1 over 12 would be equal to 1.5 over our unknown amount. Okay? Now, I don't like to work with the numbers on the bottom, so I'm going to flip them up. We're going to see this on a fresh page because it'll just be easier to work with. So, we'll take 12 over 1 being equal to x over 1.5. So we're going to need to multiply by 1.5 and multiply by 1.5. So we'll do 1.5 times 12 divided by 1, and we're going to find that 18 will equal x. So that means that this ramp would need to be 18 meters long. Here's another example where we are asked to determine the rate of change or the pitch of this roof. So again, notice how they're making a right triangle and ignoring the other half of the roof. This is because we are only concerned with the lowest point of the roof and the highest point of the roof. We see that we have a rise of 5 and we have a run of 3. So this means that our pitch will equal our rise over run, or 5 over 3. We can also see this happen when we're working on graphs. These graphs represent a staircase. As we can see, each stair moves along the grid. So for each question we are asked to determine our rate of change. Well, our rate of change is our rise of 2 and our run of 3. So that means this rate of change is 2 over 3. In our second case, we have a rise of 3, a run of 3. So we would have a rise of 3 over a run of 3. But 3 divided by 3 gives us 1. So in this case, our rate of change is 1. We're going to look at one more example to determine our rate of change. Here we see determine the rate of change. We're given 2 points. We have 1 point here at 2 and 10. We have another point right here at 6 and 30. But we need to figure out what we're actually looking at. So if we look at our graph, it has earnings running along the y-axis, and it has number of hours worked along the x-axis. So we're looking at how much money you would make if you worked a certain number of hours. First thing we're going to do is use this graph to get our rate of change. So our rate of change. In this case, we have a rise of 20, shown right here, and we have a run of 4. So if we do 20 divided by 4, we find an answer of 5. Now what is that 5 actually talking about? Well, it's comparing hours worked and earnings. So when we take our earnings of $20 and divide it by 4 hours, so $20 divided by 4 hours, we end up with a unit rate. That unit rate is $5 for every hour. This is telling us how much is being made for each hour worked. So here we see a little summary that just says this question shows that you make $5 for every hour worked. Another way that you could be asked about this is you could see a question like, what does this rate of change represent? So if we're asked what this rate of change represents, we have to consider what we're measuring. We're measuring earnings and the hours worked. So for every hour worked, how much earnings would you make? That is what our rate of change tells us. So in other words, our rate of change tells us our hourly wage. And so there we see our final summary. Okay, so we've looked at rate of change as a discussion of the rise and the run of a line. We can take that rate of change and apply it to the pitch of a roof, the grade of a road, or the steepness of a ramp. We can also use it to model real-life situations like the amount of money you would make for the hours that you work. These are all applications of rate of change. As you can see, our rate of change could be shown through a physical structure like a house or a ramp, or it could be shown on a graph. The idea is the exact same, and you will use the same steps every time. So use the information that we learned in this video in order to work through the practice questions. If at any point you're unsure, shoot me an email and I'm happy to work through the questions with you. Other than that, we're going to end our lesson here. So take care, everybody. Bye for now.